Hey, good morning everyone. So I'm going to make a video today. We're going to finish up talking about the specific parts of the periodic table just by talking about the families in the periodic table. Come on. There we go. Okay, so the first thing we're going to talk about is hydrogen. So if you think back to when we looked at the periodic table the other day, and we saw that the metals are like pretty much all on the left side of the periodic table. The only exception to that is hydrogen. So hydrogen sort of fits in a couple of different places in the periodic table. But the reason why that they put it at the top left is that they wanted to, it has some similar characteristics to the other elements in the first group, which we're also going to look at in a moment. So it's important to know that it is in group 1, like it's in that first column, but it's not actually a member of that family, and we're going to see why in a moment. So hydrogen is a gas, and it has 1 proton and 1 electron in its orbit. So it only has 1 orbit, and it only needs 1 extra electron to either gain or lose to be stable. So this is hydrogen here at the top. All of these other ones here are called, let me just move that, there we go, alkali metals. So like we just said, hydrogen is a gas. Else in this column are metals. The reason why that they are grouped with hydrogen is because all of these metals also have outermost orbit, or we call that 1 valence electron. Just another thing to, and they have the consistency of clay. You can easily cut them with a knife. So I remember back in history class in university, one of the brought a piece of sodium to, and I just remember he I thought it was the coolest thing ever, just because, well, you can slice through metal like that. But yeah, and then I found out that that was one of the properties of elements from this group. So yeah. They are also the most reactive metals. They react violently with water, and they're never found as free elements in nature. So they're the most reactive because they have 1 valence electron, and they just want to get rid of that electron. So we're going to see later that they bond with some nonmetals that are here on the other side. But yeah, they really want to get rid of that 1 electron because then it's easy for them to be stable. Now here in group 2, these are called the alkaline earth metals. So they're also never found uncombined in nature. They have 2 valence electrons, and just some of the elements, there's magnesium, there's calcium, there's beryllium here. I can't remember some of the others. I think strontium might be in that group. But yeah, so these are all in group 2. And notice group 2 has electrons. Same thing if you go back to group 1, has 1 valence electron. So that's going to be very important to remember. And there's going to be tricks for some other elements too that we're going to look at. So make sure you keep that in mind. So these elements here in the middle are called transition metals. So they're metals that you've probably heard of, like copper, tin, zinc, iron, nickel, gold, silver, maybe mercury you've heard of, or platinum, or titanium, stuff like that. That's all of these elements here. They don't have like a valence electron sort of trick to it, but we don't really have to worry too much about that. Not in this case anyways. If you continue on learning chemistry, it might become more important, but for right now, it's not important. And just another property to note is that they are good conductors of heat and electricity. Now here in group 7, this is called the halogen family. So there's fluorine, chlorine, bromine, iodine, astatine. It keeps going, but these elements, a lot of them haven't really been discovered yet. So we don't really know too much about them. But anyways, halogens have 7 valence electrons, and they are the most active nonmetals. So these ones have 7 valence electrons, and they need 8 to have a full outer shell. So all they need to do is grab one of these electrons. Now remember back here with group 1, these ones want to get rid of their 1 electron. So these elements here combine really easily with these elements here to make compounds. Another thing to know is this is group 17. And notice group 17 has 7 valence electrons. Again, it's going to be handy to remember that. We're going to look at that more just in a little bit here. This last group here, they are called the noble gases, and they are very unreactive. Like, they don't react with anything. The reason why they don't react with everything is because their outermost shell is already full. So they don't have any more room to create or to get electrons from other elements, but their shell is full, so they don't want to lose any either. So that's why they don't really react with anything. They're called inert. It's another word for saying they're unreactive. So some of the elements here, there is helium, neon, argon, krypton, xenon, radon. Another thing to know is that this is group 18, and it has 8 valence electrons. The only exception to that is helium. Helium only has 2, but for helium it only needs 2 electrons to have a full outer shell. We're going to look at that more when we start talking about and making Bohr diagrams, but it's just a good thing to know right now. And then we'll just move over here. This group here, those are called the earth elements. I believe that they're also called semi-transition metals, called the lanthanide and actinide series. That's because the elements I start with are lanthanide and actinide. For grade 9, you don't really have to worry about those elements. And in grade 10, it's good to be aware of them, but we're still probably not going to be working with them at all. So I'm just going to go to a periodic table. Here we go. Okay. Oops. Sorry, I'm just going to move me there. There we go. Okay, so here is a periodic table. It's, again, the one that is in the resources in the classroom. So here we have group 1, here we have group 2, here we have group 7 and group 8, and then we also talked about the middle. Now remember we said group 1, or sorry, I said 17 and 18 I should say. Here we have group 1 and group 2, and we said that group 1 had 1 valence electron, group 2 had 2 valence electrons, 17 had 7, 18 had 8, except for helium. Now these elements here in group 16 have 6 valence electrons. Group 15 has 5, 14 has 4, 13 has 3. So that's another good way to remember how many valence electrons these elements have. When it comes to the ones in the middle, like I said, they don't have like a neat trick to it. But yeah, it's still good to know about all of these other ones. We're going to be working with these when we talk about ionic and covalent bonding. And then we have to know how many valence electrons they have so that we know how many that they're giving and taking and sharing and all of that fun stuff. Just one thing I wanted to point out here is it says elements in the same group can be expected to behave in a similar way because they have the same number of electrons in their outermost shell. So that's, again, just reinforcing what I was saying to begin with. that's about it, what I have to say about the families. I'm going to be posting a short little assignment that goes along with this, and I'm also going to be posting a Kahoot. I'm going to leave it open for as long as you guys want, so you can do it once, you can do it 100 times, doesn't matter to me. But I'm going to post a link to that in the classroom. And yeah, I hope that you guys have an awesome spring break, and I'll see you again shortly.